Hey guys, well, we're making it to another week. We have this week and next week, and then we're done. So this has been a weird school year, but we can sail to the finish line together. Today we're going to be talking about something that you guys have never heard of before, but it's going to be something you're going to be using in geometry in ninth grade and probably some more after that. So it's going to be something you're going to need to be familiar with. And it's called the Pythagorean Theorem. Pythagorean Theorem. So the Pythagorean Theorem is named after a guy named Pythagoras. He was a scientist and a mathematician, and he loved geometry. And so the Pythagorean Theorem only is associated with right triangles. So in your packet, I'm on page D. Okay, at the top here, I want you to say right triangles only. This theorem, and what I'm going to teach you today, is only applies to right triangles. So here we know this is a right triangle because there's a 45-degree angle here. And so that's a right triangle. So you guys know what a right angle is. It's 45 degrees. Okay. So what a theorem is, it's a let's see. It's something in math that you'll hear a lot that it's a statement. If this and this is true, then this is true. That's a theorem, okay? So it's kind of like an idea, all right? But it's proven true. So it's not just a hypothesis, all right? So this is a triangle, a right triangle, whose sides have a length of 3, 4, and 5. So we're going to go ahead and we're going to label A. So here's the triangle with in another way drawn over here. The same triangle. Okay, here's the right angle. Okay, you have side A. This is side B, and then side C here. Okay. So side A is 3, side B is 4, and side C is 5. Okay? So that's what they tell you right here, 3, 4, and 5. Alright, so if we go to our picture here, we can see A is 3 squares long, B is 4 squares, and C is 5 squares. Alright, so it's the same thing here. Alright? So now what we want to do is we're going to square each side. So that's why you have each of these big squares coming off each side. I want you to square them. So when we say square them, that means multiply each side by by 2. I mean by the same number. So 3 squared. So this is going to be 3 squared, 4 squared, and 5 squared. Okay? Which is what you have up here. You have 3 squared here. That's 9. There are 9 squares here. We have 4 squared here, which is 16. There are 16 total squares here. And then up here we have 5 squared, which was 25. There are 25 total squares over here. Okay? So we just squared each side. Alright. So count up the squares, which is what we just did, associated with side A. Did I mention the number's 9? Yes, this 3 squared is 9, so that's why this is the squares here, side A. Okay, so side A had 9 squares. Side B, which was 4, right? 4 squared was how many squares? 16. It had 16 squares. And then side C was the one with 5, and it was 25 squares. Okay? Alright. So here's our man Pythagoras down here. It looks exciting, kind of looks creepy. But the Pythagorean theorem, which is mine, he says, was invented by me. It was an original idea of mine. If someone tells you that some silly Babylonian thought of it first, you can tell him to shove off. By the way, can you discover it for yourself? But don't forget, I did it first. Alright, he's pretty proud of that. Alright, so do you notice a relationship between these 3 numbers here? 9, 6, and 25. I'm sorry, 9, 16, and 25. Do you notice any relationship between 9, 16, and 25? Alright, maybe you can see this, maybe not. Here's a little hint. Try adding side A, which is 9, and side B together. 9 plus 16. What does that equal? 25. And you get side C. So this is A, this is B, this is side A squared, this is side B squared, and this is side C squared. Okay? So because A was originally 3, 4, B was 4, and C was 5. So when you square those, A squared plus B squared is going to be C squared. What do you find? So A squared plus B squared is always going to be C squared. Now, here's the kicker. In a right triangle, there's always going to be an A side, a B side, and a C side. So let's go back up to the top here. Your shortest side is always going to be your A. That's your shortest. You can think of A as the first letter in the alphabet, 1 is the lowest number. I don't know. B is always going to be your longer side. And then C is always going to be the longest side. And the longest side on a right triangle is always the slanted side here. This is always, always, always going to be your C. And we call this, does anybody know? I don't know if y'all learned this in 6th grade or not. It's a weird word. It's called the hypotenuse. Hypotenuse. Okay? So your C is your slanted side. It's called your hypotenuse. Alright, so now that we know that, let's flip to the back. Okay? We're on page E. So I'll give you a little bit to get there. Alright. So we have Sophie here, and she's, well, Sophie, you're so popular, except for, we used your name last week. Except this is with an F, right? And our Sophie Frost is a PH. But anyways, it's a very common name. Sophie is trying to create a right triangle with this length side 4, 5, and 6. Okay, so let's draw that. Let's go up here and draw that. There's my right triangle, right? This is going to be my A, which is the shortest side. What was that? 4 centimeters. This is my B, which is the next longest. That's my 5 centimeters. And always, always, always the slanted side is your C, your hypotenuse, which is 6 centimeters. Okay? I just drew that with Sophie's draw. What she's trying to draw. Okay, so we just drew what we think is a, let's see if this is could really be the dimensions of a right triangle. And to test that out, we're going to use Pythagorean Theorem. Can Sophie create a right triangle with these dimensions? Well, we don't know yet. We sketched what we think it could look like, but we don't know if this is really, could be true to size. Like, if this was 4 and this is 5, would this be 6? Well, we don't know, but we can figure it out by using that theorem. So here's how we're going to solve it. We're going to do step 1. Step 1 is the length of our longest side of Sophie's triangle, which is her hypotenuse. What was that? 6 centimeters. Okay? Right up here. Then, the lengths of the 2 remaining sides, what we call the legs, that's our A and our B, were 4 centimeters and 5 centimeters. Okay? So step 2, find the area of the square that would be made of the hypotenuse of Sophie's triangle. So what they want us to do is take C and square it. So area is going to be 6 squared, which equals 6 times 6, which is 36. 36 centimeters. That's the area of the hypotenuse. Okay? And then you're going to find the area of the squares on the legs of her triangle. The area of square on leg 1. Leg 1 is our 4. So that's going to be 4 times 4. Okay? And that's going to be 16 centimeters. And 2 was 5, leg 2 is measurement is 5 centimeters, so 5 times 5 would be 25 centimeters. So this is the same, when I say 4 times 4, that's the same as 4 squared, and then 5 times 5 is the same as 5 squared, okay? So we just did a squared and b squared. That's a squared, and this is b squared. Okay. Add these two areas together, because that's what Pythagorean theorem says. It says a squared plus b squared is going to always equal c squared if you have a right triangle. So let's add a squared, which was 16, and b squared, which was 25, together. What does that equal? 16 plus 25. That equals 41 centimeters. Okay? Now, using your knowledge of Pythagorean theorem, explain the relationship between the area of the square on the hypotenuse and the areas of the square on the legs. Okay, so what do we know about Pythagorean theorem? Which two sides of the triangle squared, if we add them together, what would it equal? It's going to equal that slanted, that hypotenuse, that c. So a squared plus b squared is always is going to equal c squared. So the short one leg squared, the medium leg squared, added together is going to equal the slanted, the hypotenuse squared. Now, it's very important that you guys see that you have to have this square in here. You can't just add up a plus b equals c. That's not what his theorem says. His theorem says a squared plus b squared is c squared. So, now step 5 is, let's look at what we found out. A squared on Sophie's triangle was 16. B squared was 25. When you add 16 and 25 together, it gave us 41. Is 41 a square? Is that a perfect square? No, it is not. It is not a perfect square. Because, let's see, 6 squared is 36, and then 7 squared is 49. There is no 41 perfect square. So do you think Sophie's triangle is going to be a right triangle if those are her dimensions on the sides? No. Because 4 squared plus 5 squared does not equal, so we're going to draw a line through the equal sign, it does not equal 6 squared. It equals 4 squared plus 5 squared, here is 41. 6 squared is 36. Okay, so it is not a right triangle. We know that because it does not fit Pythagorean theorem. So let's get our notes right quick. And we're almost done here. It's going to be a shorter one today. Pythagorean theorem. Okay. Only applies to a right triangle okay, that's the key. If the triangle you're looking at is not a right triangle, you cannot use Pythagorean theorem to figure out the sides, the measures of the sides of the triangle. Okay, so we're going to draw a right triangle, and let's label this is our right triangle. We know it's a right triangle because it has a right angle, 45-degree angle. Our short angle, our shortest side, not angle. B is our medium side. So here's our B. And C is our longest side. Also a slanted side. And we have other names for these sides. We call A and B, we call those legs. Paxton, thank you. Back up. And then C we call hypotenuse. Okay. I forgot to label C. Okay, there we go. So what his theorem tells us is this. It tells us that if we take the measure of angle A and square it, and we add it to the measure of angle B squared, that's going to equal the measure of angle C squared. Alright, so let's do that one that we did earlier. Let's do another example, actually. I'm going to give you a moment to get all that written down. Alright, let's do another one. Okay, this is our right angle. Let's say A is 5. Let's say B is 12. We need to figure out what C is. Okay? So we don't know what it is. But using our Pythagorean theorem right here, we can figure it out because it is a right triangle. And so it's going to, we can figure it out. Okay, so A squared plus B squared equals C squared. Well, A is 5, so we're going to square that. 5 squared, and that is going to equal 25. B is 12. 12 squared equals what? 144, right? 12 times 12. So A squared plus B squared equals C squared. So we have 25, that's A squared, and B squared was 144. If we add those together, what do we get? Or you can use a calculator now. So 25 plus 144 is 169. Okay? How do you think we could figure out what C is if that's what we get when we add them? It's not, C is not going to be 169, it's C squared. So how do we get from a square back to the original root number? We take the square root. Okay, so what times what equals, what times itself equals 169? Well, you probably know it, but if you don't, there's a way you can figure it out on your phone. It's the square root button. So, trying to find it here, it looks different. Alright, so what we have to do is we have to put 2 square root, we have to put the 2 in to tell it what root it is, and then that and 169. Nope. No, that's not the right one. Oh, here it is. The square root's right here. Duh. Okay, so this one right here. 2 squared. So 169 square root. That's it. The 2 square x right there. That's the square root button. So you put the number in first, 169, and then you press that 2 square x, and it gives you the square root of 169, which is 13. It's the same thing as 13 squared. So what is C? C equals 13. So that's a common Pythagorean theorem. We call it the triple. You have, we did one earlier, which was 3, 4, and 5. And another, these are common triples, 3, 4, and 5. And then we just found out that another one is 5, 12, and 13. Those are common Pythagorean theorem triples. Okay, so that's where we're going to stop today. And then next week, we only have one more video left, and it is completing page F. So, a lot of you might be able to figure this out now. You can go ahead and start doing this on your own, and when you finish this and the regular math, you can go ahead and fill in that answer document in Google Classroom and submit that, and you're donezo with 7th grade math and pre-algebra for the year. Okay? Or you don't take pictures of it and send it to me. Don't do IXL. We're doing option 2 of regular math in the packet and the pre-algebra supplement. Or you can just go and turn in your packet once you're finished with everything in your packet, and then I will get that documentation as well. Let me know if you have any questions, and I will be Zooming with you guys on Tuesday at 2 o'clock. I will see you then. Bye.